the technical difficulties there. My name's Nathaniel Davenport. I'm here from Monarch. I'm a senior product manager here, leading the product development for all of our dairy-related technology and products. So today we're going to talk a bit about digitizing and automating feed pushing, but we're going to start with just kind of giving you a background about Monarch and what we do here. So we are the world's first commercially deployed, software-defined electric autonomous tractor. Company's been around for a little while. We launched this tractor back in 2022 in December, and since then we've delivered about 500 of these out into the field. And they've been commercially deployed across a lot of different crop types: vineyards, solar farms, orchards, dairies, municipalities, and we have hundreds of thousands of real-world operating hours, both manually and autonomously as well. And really what this tractor kind of has been about at its core is delivering a lot of efficiency gains, sustainability goals, and operator safety. Today we're going to talk a lot about automation, but I just wanted to kind of briefly mention a bit about some of the benefits of the manual usage of our tractor as well. So this is one of our dairy customers in Ohio here, and they're just running the tractor manually. They're using it to help meet some of their ESG goals as defined by some of their commercial partners. And they're seeing a lot of value come out of it through the electric savings, through the cost savings through diesel as well. And additionally, because it's a software-defined tractor, we can deliver a lot of those efficiency improvements and updates through over-the-air updates. And all of that is made possible through the kind of brains of our tractor, or the smart roof. So this is where a lot of the sensors, like our 6 mono cameras that give us this 360-degree view of as the tractor moves throughout its environment, as well as our front and rear stereo cameras, which have 2 cameras kind of like our eyes that give us depth perception as we drive through an environment. We have work lights, which are great for manual operation, as well as enabling nighttime autonomous operations as well. This roof is more powerful than your computer at home. We have a bunch of GPUs and CPUs in there to enable us to run a lot of intensive machine learning models that we'll get into later that enable our autonomous operations. Additionally, it has all the kind of connectivity that you would come to expect: Wi-Fi, LTE, Starlink capable, and then dual GPS that are RTK corrected as well. All of this enables some of those OTA updates that we talked about: telematics, live video streaming, remote control and autonomy, as well as a lot more too. So this is kind of the brains that enable what we're going to talk about in a bit. So why feed pushing? Our tractor initially kind of launched in vineyards and some more specialty crops, and then we kind of slowly looked into dairies. I'm sure, as like most of you guys know here, feed pushing is a very kind of monotonous 24/7, 365 operation that often falls behind. Often a lot of dairies don't even have a dedicated guy to go feed push. It's just whoever's free to go run out and push and try and do consistently. But that's falling behind due to a lot of labor shortages. And so that's kind of one thing that we're looking to solve for here. Is this is an operation that's ripe for autonomy. It's generally the same route that people are doing throughout the day, all good? Cool. Same route that people are doing throughout the day, same implement, same operation. There's not too much variation. So this was kind of the low-hanging fruit in terms of automation on a dairy farm. Obviously, labor savings is one component of it, and it's really labor augmentation, allowing the same amount of workforce to go do other stuff on the farm and not have to worry about feed pushing. But also with more frequent feed pushing, and if there are any dairy nutritionists in here, I'm sure you can hopefully back me up as well, is that almost nobody is pushing as well or as much as they are supposed to be doing. So with autonomy, we can push more frequently, cows are going to eat more, and hopefully produce more milk, and that's more revenue for the dairy. So we're saving on the labor side, but also increasing the revenue that our customers are seeing too. So it's kind of both sides of the coin there. Now, to get into actually, how this tractor operates autonomously, and this really is the first of its kind in terms of doing autonomous feed pushing. Right? They're small little robots, but this is a full-size, 50 to 60 horsepower tractor with a 3-point hitch. It can go on dirt roads. We're not confined to just metal tracks in the ground. And because of that, it's a little bit more complex, but we'll get into how that works. The first thing that we do on a site is first install a base station to give us those RTK corrections, but then we're going to go and map out the farm. The first thing that we're going to do is map out a geofence or autonomy boundary. This means, an area where the tractor can operate autonomously. It's not going to go outside of this. You're not going to see it running away down a road or something like that. The next thing that we map out, and all this mapping is done with the tractor, is very simple, kind of just drive around the perimeter, is any sort of obstacles or keep out zones. These are, things like fences or a parking area or basically anywhere you don't want the tractor to drive. After that, we'll go through and map out the feed lanes, or where we actually want the tractor to go push. This is super simple, just as easy as lowering the blade and going and pushing feed down a lane. And how it's actually working is we're using the cameras on the tractor to see where that stanchion and those curbs are, and based on that offset, actually map out the real physical location of that stanchion and curb. And because the tractor has a fixed blade kind of on the right-hand side, these are mapped out with the directionality so that we always know we're going to push it on the right side and do it correctly. So after we've mapped out the dairy, we're pretty much ready to operate. And what that looks like actually from an operator standpoint is through either the Wingspan AI app on your phone, this is our Monarch's mobile application, or through the website, Wingspan AI website on their computer, so you can do this in a nice air-conditioned office. You'll first connect to the tractor, locate it on the map or through your list, and find the tractor, connect to it, and then you're going to go on your map and select which lanes you want. The nice thing about this is, operations change, so you can select whichever lanes in whatever order you want to push them in. So it's not a predefined or pre-recorded operation. It can be dynamically adjusted. After you've selected your lanes, you're going to go in and select a blade offset. So everyone knows feed throughout the day changes, and you got to kind of push closer throughout the day. So in here, you can set that up. And maybe you feed a little bit more to the milking cows, less to heifers or something like that. You can have a customized offset for each of those lanes as well. You'll also select a return to start here. This is an optional thing. So this means that the tractor will return back to its starting position and orientation. That way it's ready to be sent out for another run, an hour later. After all those parameters are set, you can generate a path, review that path, make sure it's going to the right spots, and then you're good to go and you can start your operation. And this is actually what that looks like here kind of in a short video. There you can see a quick snapshot that you'll see of the tractor, the front camera, just to make sure you're selecting the right vehicle. You can adjust that speed from anywhere from 0.5 to 4.5 miles per hour. After that, you'll select your offset here, turn on the return to start. We'll get into the preset operation in the next slide. But here you have your path, planned path for the tractor that you can review and then go start pushing feed. So if some of that looked like a little bit complicated to you, you don't have to worry too much. We have these things called preset operations where it's a selection of lanes, a blade offset, and return to start. As we know, most of those operations are going to be relatively the same day to day. So you can set up these presets and then just with basically 2 clicks, get going and start running an operation right away. So while the tractor is actually out and operating, what's it doing? How's that working? So this is a video here of the tractor driving manually with what we call one of its segmentation models running on the right-hand side. So as the tractor is actually out navigating throughout its world, this is a manual driving too, not autonomous, so you'll see it kind of move around to showcase the model. It's picking up its surroundings, and we're running a bunch of AI machine learning models to segment out its surroundings, and basically the tractor is able to understand what the different things are throughout its environment. That way that we can detect obstacles and we know what they are, what to ignore, what not to ignore. As well as it's navigating down those lanes, it's actually using vision when it's inside the lanes to do that navigation. And we'll get into why that's important a little bit later as we look towards covered feed lanes and things like that. But it's very different than how a lot of other vehicles out there or other machine or feed pushing robots are operating on like a track basis or using ultrasonic sensors or things like that. This is a lot more of a robust solution. Additionally, as we're going throughout there, we're also detecting humans and vehicles. Sorry, this one isn't playing, I guess. But as you can see here, we're detecting some vehicles there and humans as well. So those models, as the tractor is going through, it's picking up those, and with some accuracy, it will alert you if it sees somebody within its certain radius. And we have different parameters based on humans, vehicles, cows, and generic obstacles of how close the tractor will start to slow down, then come to a stop, and then notify you if it can't move on. And what that actual workflow looks like is, as the tractor detects a human, vehicle, or obstacle, it will try and resume for 20 seconds if it identifies one of those things. So if a golf cart's just driving past the tractor, tractor starts to slow down, and then the golf cart moves away, the tractor will continue on. You don't have to worry about it. Won't even notify you. You can go back and review it later if you want to, but it's not going to interrupt your operation at all. Now, if that obstacle doesn't move and the tractor comes to a stop after 20 seconds, you'll get a notification on your phone, like a text message, and then you can go into the app and review that obstacle detection. And what you'll see is kind of a small little pop-up there and a thumbnail image from where the tractor actually detected that. So if it was behind the tractor, it'll show you it there. If it was in front side, and you can blow up that image, take a look. Is that thing actually still there, or did it move on? Am I safe to resume? And then if you are, you can resume from there and then continue your operation. As we know, dairies are always very, as much as we want to keep the lanes clear and things like that, when we're running autonomy, they're generally very busy environments. So this robust human obstacle vehicle detection is important for those dirty environments. One of the kind of big misconceptions about autonomy is that it's, we map and then we're done and that's it, and it's super simple, easy. This is a really, really new technology to the market, especially for this size tractor or vehicle. And so autonomy for most of our customers is really a process. So we work with customers very closely on this kind of phased approach for how we work with them to roll out these autonomous tractors on their farms. So that phase one is going to be manual operations. So first, an electric tractor, especially one with software running on it, is a little bit different than what most of their operators are used to. So we want them to get comfortable with it operating manually, first of all. So they're comfortable with the base machine before they start doing more complex autonomous operations. Once they're comfortable operating it manually, then we'll move on to phase two. Our field personnel will come on site. We'll work with you to map out your dairy. We'll work with you to kind of understand how you want your operations to function, where to map out those keep out zones and things like that. And then we'll train your operators in person and stick with you as you kind of do those initial autonomous operations to make sure you're super comfortable operating. Now in phase three, one thing that we saw is like a lot of the employees on our customers' dairies, initially were a little bit skeptical of autonomy and didn't necessarily trust it. So even though we weren't having any issues. So this phase three portion is when we have customers, operators sit on the seat of the tractor for those first 10 hours of autonomous operations. And what that means is they actually get to see the tractor without them actually doing anything, see the tractor function and work as it goes through its environment, stop for an obstacle detection or something like that. And it makes the operators feel a lot more comfortable about this machine operating on their farms. And 10 hours isn't, super burdensome. For a lot of dairies, that's really only a day or two of feed pushing. And so they get through it pretty quickly, and it really makes their operators feel a lot more comfortable. In phase four, after those 10 hours, that's when our customers move into fully off-seat autonomous operations. So for them, this is really where they start to see kind of the value of the labor savings and increased efficiency of autonomy. Now from our end, we still have what we call MCC or Monarch Command Center, remotely monitoring the customer operations. And really what that's for is mostly for us to be able to collect more data about how our tractors are operating, and see any issues that come up, and be able to kind of improve our autonomy as it goes forward. Additionally, they're there as kind of a support system for customers who can message them easily through a chat function within our app, and get any support for issues that they might have right away. Then after phase four is phase five, where once customers are comfortable running, they're consistent, and everything's going nice and smoothly, we remove the requirement for MCC, and they're just kind of running off on their own now. The other kind of big misconception about autonomy too is that it works everywhere. And as much as I wish that were true, it's not necessarily the case. So we have what's called an operational design domain, or we abbreviate it as ODD, or what the tractor kind of has been, the environment that it's been designed to operate within. So for right now, with the Mark V tractor and auto drive feed pushing, we've designed it mainly to operate on outdoor open lot feed lanes and dairies. There's a few more kind of specifications in terms of what sort of turnaround space we need, and we can't handle dead ends and things like that right now. But we work with our customers to understand their operations and where it will and won't work on their farm, and if it's the right solution for them. And we're kind of constantly expanding and improving this ODD in terms of shortening that turnaround space, or looking at how do we handle gates properly, and things like that, curved lanes, and really what we'll get to next is covered lanes as well. So in terms of that continuous improvement, one of the big things there, obviously, for a lot of people, especially around here, is freestall barns, or kind of covered operations. So this is something that is in beta testing for us right now. We're working with a few of our customers on beta testing this. It hasn't been commercially released, but we're planning on releasing it this fall. There's a number of challenges that come with these covered lanes in terms of GPS denied environments, right? As soon as we enter in here, we lose GPS signal. So what we have to do is use things like visual odometry, where we're using the cameras to estimate the tractor's position within the lane, as well as encountering those cattle crossings and cattle guards like you just saw there. So those, we actually had to develop a new machine learning model to be able to recognize those cattle crossings, because we can't map them out because we don't have GPS. So our tractor's cameras are actually recognizing that cattle crossing and raising the blade there, moving into the center of the lane, crossing it, and lowering the blade again accordingly. Now at the end of these turns here, we're getting that GPS signal back again, and reconfirming the position of the tractor, and then re-entering the lane again to then go and push feed. So this is very challenging environment for a tractor to operate in, and we're excited to be pushing this out soon. I'll let it finish up here, but yeah, you can see as we're navigating down here, it's entirely based on vision. We have no GPS here anymore. And as we encounter that, we're going to raise the blade, drive up over it, and I think the video pauses right about here. Now, that was a lot about autonomy. So what actually happens when the tractor's out there operating. On the other side of things, once it's done operating, the tractor's out there collecting a ton of data. How does that actually help farmers? So there's a few different kind of fundamental questions that we're trying to help farmers answer. One is, what did the feed actually look like out in the lanes when the tractor's out there operating? The second is, did feed pushing actually happen on time? Right now that's usually a word of mouth type thing, or sometimes a lot of farmers don't even know if the feed pushing actually happened or not. And the last third thing is kind of how, based on this information, how should I be adjusting my feed for the next day, right? Should I be feeding more or less? How can I save money there? So one of the big things here is, on our Wingspan AI platform, customers can go back and look at past operations, and they can actually review the video footage from the tractor as it's operating within those lanes. So they can go back and see at 1 a.m., 2 a.m., 3 a.m. When my guy's out there pushing, what did the feed actually look like? At 7 a.m. when I'm doing the push out, maybe the lane 2 is out of feed, but I don't know what time it actually ran out of feed. So here you can go back in and really see that information, and that's super valuable for a lot of our customers. The second big thing here is our weekly feed pushing report. So every Monday, our customers get emailed, and they can view it on the Wingspan AI platform as well. This kind of relatively brief, easily digestible report for that kind of farm manager, owner level, to be able to go back and look at each of my sites. How did my operators actually perform for feed pushing? And we can break this down site by site. You can assign your tractors to different sites. And this will account for both manual and autonomous feed pushing as well. So even if I'm out there manually, we'll still be tracking and recording that feed pushing, and it'll be included in here. Additionally, you can set target goals for this site. I want it to have done 15 rounds of feed pushing every day, and we'll be able to highlight if you missed or went over that goal as well. So just kind of a very high level what actually happened out there on my farm. Now, everything I talked to you today is available right now in the Mark V tractor. but really, Monarch as a company, what we've noticed, out in the industry, a lot of, across the board, there's been, a lot of need for digitizing, automating, and decarbonizing vehicles all the way across the ag space and off-road industry. So, people are wanting to improve productivity, make smarter decisions, and we see a lot of digitization all across the industry. Additionally, on the automation side, improving efficiency, reducing labor needs. We see it always labor scarcity is everywhere. And then a lot of ESG and environmental goals, from larger companies that they want to meet those goals. So really going forward, we see a lot of vehicles trending in this direction, and we're hoping to be able to help other companies reach those goals with the Monarch One platform. So the kind of pillars of this are the Monarch OS, which is the software that runs on the tractor as well as any other vehicle. The cloud, which is all of our cloud-based apps, software, and data that's stored in there. And then the smart applications like auto-drive feed pushing or mowing in a solar farm. We can put those onto any different vehicle, and we're looking forward to working with more OEMs across the industry to achieve that. So hopefully you'll be able to see this feed pushing technology on not just our tractor, but other vehicles as well in the future. With that being said, thank you guys very much. If there are any questions, please feel free to ask. We'll also have a tractor in the booth. If you kind of go down to the end of this hall, we'll be down there. You can see it in person. Be happy to answer any questions there as well.
Yeah, thanks for that presentation. One of the questions would be that dynamic setting. So can I go that way, the whole route, one direction, and next time or next go the reverse of that same direction?
Okay, so I think you're asking, like, can we push a feed lane two different directions? Is that kind of what you're asking?
Correct. Like one feed lane, one way, say the first time going that way, and the other way next time I come by, I want to push it this way.
Gotcha. So right now, the blade is fixed on one side of the tractor, so we can only push in one direction. It's just kind of a physical limitation. And really, that it just makes kind of the autonomy a lot easier, not having to deal with moving implements and things that are attached to the tractor, if that makes sense.
One other question: have you tested it in really cold environments? Like, is it?
Yeah. So we have a few tractors kind of in this area in Kansas, Ohio, Michigan. Battery holds up well. It's designed to operate in those environments. You'll see a little bit of a reduction in runtime. So for feed pushing, we get around 14 hours of runtime. So you see a little bit of reduction in that.
Before a charge? You're saying,
yeah, before charge. Yep. And then you'll see kind of typical things like you would on a tractor as well, like slowing in hydraulic response and things like that with cold weather. But we do have a cold weather mode on the tractor where it'll keep the hydraulic pump running and it'll keep the oil warm.
In charge time?
Charge time depends a little bit on the charger, but 5 to 6 hours. Yeah.
What's it cost?
Good question. Aaron's right there. You can talk to him, but depends on kind of exactly how you configure it. But it's right around $100,000 for the tractor itself. And then if you do want to do autonomy, auto drive feed pushing, that's a yearly subscription as well.
Can it make a 3-point turn or something, like back up, maneuver around a little tighter?
Yeah, that's a good question. So right now in the feed lanes, we can't do the 3-point turn in the lane. So we need a kind of a free open lane with no gates to be able to turn around. That's something we're working on though, where we'll be able to basically go down a lane, see a gate, stop, reverse out, and then reverse back down again.
Open and close garage doors?
Again, something that we're working on too. So that we will probably end up working with kind of a dealer in the area to install some sort of automatic door opening system. So that's definitely possible. And the great thing about the tractor too is, as I mentioned, we're always improving its functionalities and capabilities, and we can send those updates out across the fleet remotely through over-the-air updates. Same way your phone, gets updates from Apple every single year.
How much is the subscription for the autonomy?
For the autonomy, it's right around $18,000 a year. That's a great question. Oh shoot, Aaron, I'm gonna forget the warranty and I don't want to mess it up.
Warranty right now on the tractor's 4 years, 4,000 hours, and the batteries 8,000 hours and a fuel.
Yeah. So that's the warranty. It's designed for a 10,000 hour lifespan. But yeah.
Service, grease zerks.
So since it's an EV tractor, we like to say there's over 70% less moving parts, less maintenance that has to be done, right? So it does have some research that go with the tractor on it, but it really only has two. It has hydraulic fluid, it's hydraulic fluid running on the tractor, and that's 3 points of that. But it does have a coolant for like the motor on the truck. That's the only two things on it. It does have some research. It has two passive coolers on the front end of it, so that way it pumps in inside the front end. Is it cooling the fluid? Yeah. The hydraulic fluid in it is cooling the fluid circulates it, so yeah, it's cooling that cooler.
Are you guys thinking about pulling the feeder wagons next, or what are you thinking about next?
Feed wagons are a tough one, at least like in a lot of the dairies where usually a lot significantly over the weight limit of our tractor. There's some smaller ones. We've looked at some calf bottle trailering kind of operations and things like that as well. But yeah, I mean, as I said with the Monarch One platform, we're definitely looking to talk to other people about integrating our technology into their self-driving grain wagons and things like that.
So the 14-hour run time, can it push feed for 14 hours?
Correct. Yeah, that's for feed pushing. If it's going to do different operations like mowing or something like that, you'll get a slightly lower runtime there because it's a lot more power intensive. But yeah, feed pushing 14 hours continuous.
So if we want to push feed 24 hours a day, we kind of need 2 tractors?
Yeah. So totally depends on your dairy, right? If your dairy takes 30 minutes to do a run, right, and you can go and do a feed push run for 30 minutes and then come back and spend 30 minutes on the charger, then you're all set for 24-hour operations, right? Because you have some time to charge. If you want to feed push every hour and it takes an hour to do that route, then yeah, you would need more than one tractor to accomplish that. So it just kind of depends on how frequent you're looking to push feed and how long that run takes.
My question was basically a trickle charge. If you were getting done in 45 minutes, you had 15 minutes. What does that look at? Yeah, I guess that's going to. What time difference would that make? You're pushing every hour.
Yeah.
And you had 15 minutes to trickle charge of that hour. Could you go 24/7?
Yeah. For that specific ratio, I don't know if I'd be able to answer it exactly. But yeah, we can definitely work to kind of do the math and figure out what would be the right call there for sure.
How fast do you push feed with it? What's practical?
Yeah, so right now, just for our autonomous operations, it's anywhere from half a mile per hour, which I know is very slow, to 4.5 miles per hour. And the reason we kind of limit the speed is mostly for safety and giving us enough time to be able to come to a stop if we do identify an obstacle or.
So you could push feed 4.5 miles an hour for 14 hours?
Correct. Yes.
Okay, because we've got a location with several miles of feed alley.
Oh yeah, yeah. Yeah, so we have a few on larger dairies like that, and most of those guys are running more than one tractor to be able to accomplish kind of that 24-hour, 24/7 pushing. But yeah, as I said, I've helped our sales team kind of spec out what the right number of tractors is for specific operations, because it really does depend on what you're trying to accomplish and what type of charger you want to install and things like that.
Yeah, there's been really, like you were saying, there's like 3 different scenarios that we really have taken off. There's either they're running 24/7, and so they have 2 shifts of people coming in, and so when one shift's done, say 12 hours, we'll say for argument here, they put their charger on the tractor. The next person that comes in takes their charger off the tractor to run it, and so it did take 2, and they run nonstop. But those are large operations. And then another one is they stopped. They don't push while they're putting feed out in the morning and feeding the cows, and sometimes that took anywhere from an hour to 2.5 hours. And with an 80 amp charger, we're getting enough. They plug it in during that time. They're getting enough charge to keep it up to run it to run it for their allotted time that they want to push. And
Yeah.
then the last option was like you guys have all said, like if you're pushing every hour and it takes half hour to 40 minutes, and then I go put it on the larger charger that we offer for a small portion of time, you can trickle it in and it works out. So it doesn't have auto docking. It's just like a car. Right now, our car, our electric truck, you have to plug it in at the moment.
Yeah.
Yep.
Yeah, you'll get a notification when your operation has ended, so you'll be able to see that. And exactly, and it's very configurable where we can start the tractor from, right? It doesn't need to be right at the start of that first lane, so you can have it start from over where that charger is, or let's say you set up your charger right by your office, and you can even see when it comes back. So we've worked with people on that as well.
So you were showing in your video, you were showing the picture of the an open lot with a covered top, right? Like a typical Western, South, whatever.
Yeah.
What about these sort of Midwest and sort of pretty much closed sides, like with garage doors? Is there any differences, or is it comparable, do you think, between the two systems?
Yeah. So kind of a lot of the cross ventilated barns and stuff like that in the Midwest, we just need to be able to exit the lane and do a U-turn outside so that we can pick up that GPS signal. Just for right now, there's some drift while we do drive down the lanes. So we need to be able to pick up that GPS signal at the end of the lane when
or
we
you do
that
25
U-turn.
feet at the ends.
Yes.
So
For the covered lanes, the requirement at the end is a little bit larger, just because we need a bit more space to do that turn and pick up that GPS signal. So that requirement's about 40 feet for the covered lanes. Yeah. It can reverse. We just don't have that technology commercially available yet. It's something that we're testing right now. But you can drive it manually in reverse too. Yeah. It has a reverse gear. It has three reverse gears actually.
All right, thanks, guys.
Yeah, thank you, everyone. Appreciate it. We're in this hall here. If you just kind of stick to the right side over by the concessions and go all the way down, we're two rows from the end down there in the big exhibit hall. Yep. And yeah, you can search our name online on the map as well, and we should pop up on there too. Monarch Tractor.